So we've covered kind of the instinct where you just create the rectangular block, make the shape, and do the cut extrude. But maybe that's not the best way to do it. So we did sketch fillets, did our arcs, did all that stuff on the second face. All right. So now we're back to sketch one. So instead, what we want to do for a part like this, especially for one that has a lot of different relations, we want to start by thinking, how much detail can we get in a single sketch? So clearly some of the overall dimensions are important. So let's start with a few of them. So 64 millimeter overall length. So let's start with that. Then we'll come back in for some of the key information about the radii here. All right. Yeah. .64 millimeter overall height. We're going to need. So we look around, and see. We don't have an overall height listed, so they didn't make it easy on us. All right. So we got to figure out, is there some other way that we can come together to figure out our overall height? Because it'd be nice if they gave it to us on this part of the drawing, but sometimes they're going to let you infer information based on what else is in the drawing. So we have some information about a radius here, and then the radius of our fillet to the edge. So let's start with that. So radius 76.64. So we're going to do just a little bit of a rectangle. Nope, rectangle. Every once in a while, it's going to give you completely the wrong thing. So we've got a rectangle. We're going to come back to resizing this in just a second. And there's a couple ways that you can do this. I'm going to show a different way than what I showed on Tuesday. So our sketch for the profile is actually going to be this cross-section view that we're going to focus on for a second. And we'll come back to why here in a second. So 76.64. Yeah, 3-point, because you'll see. $76.62. And we're going to do something even more interesting here. So 76.62 we're going to find the center line of this. And we're going to do something drastic. All right. So I'm going to fix some references to this center line. It'll become clear why later. I need the midpoint. Give me the midpoint. There we go. Not the angle. The midpoint. All right. Very important distinction there. Oh, that's right. They really don't want these to be used in this way. So 3 millimeters comes from right here. Our top view telling us what that section is. You'll notice there are fillets in the drawing, so some of those details are going to matter. You'll see why here in a second. But what we're actually going to do is create, instead of the entire drawing, all the curves, all the arcs, etc., we're going to recreate this. Nope, I need to break that relation because I need the end point on this arc to move. To this, I'm going to have to, because it's not going to let me move it and I'm too lazy to move it manually, I'm going to delete that and redo it. So this actually needs to be attached here. This is going to be somewhere down here. Radius 76.64, I think it was. Yeah, 76.64. So our radius. We're going to come back to this shortly. This gives us now the opportunity to do our lines. So we have some kind of a line, some kind of a thing, and some kind of a line. All right. Now, this overall height, we've got sort of some information about. Here to here, 25.54. So we've got some information, and here to the bottom of this is about 18.26. So going back to this, we're going to use a little cheating, just slightly. $20 millimeters. It's a little bit much. 1 millimeter. It's fine. Now the height difference between this point and this point is one of the ones that we have to set. So let's go find what that was. So that's another key. I think a couple of those dimensions are not on your drawing, your PDF. So this 18.26. It's the number I'm after. Okay. And the overall height then, so we have our radius, we have this. We're going to see on this one, got one more 25.54. 25.54 from that front ledge to the top, but that is filleted also. So we're going to come in here. We're going to royally mess with stuff. And then set the height here to be, let's go double check the dimension. Oh, from there to the top, 25.54. That's right. So this one we're not doing, but we will do this. $5.54. We go see what that angle was. 24.06. So this part is the long labor intensive part. I'm going to do one more thing. These are already perpendicular to each other, so I don't need to set a distance relation. I do, however, need to set a length for this. And that is something like 7.7. Yeah, 7.07. All right. Overall distance between those 2 points is 3.32. Interesting. So with this fillets, I can't actually grab there where I need to be. It's very interesting. All right, so that one we can't change because it's still going to save it as a driven dimension, even if we're telling it to be a driving dimension. So our separation there, how does it compare? 1.32. All right, so that does need to increase. what we do there is we delete that angle reference. That will let us set up from 0.32. Now we can update the angle. They're staying perpendicular, so that's good. So I'm going to cancel out of that and leave it alone. I'm going to step out of that Smart Dimension tool using Escape. In fact, I'm going to use Power Trim. There we go. Trim the closest. Close this end of the line. Okay. So we've got more or less our base geometry here. Now we have one more knee in the curve. Has anyone figured out what I'm up to yet? There you go. So I'm trying to get all this detail into the one sketch. All right. Slot 6, 5.65. So let's do that next. .65. Okay, we're going to cut that because I no longer need this. And we're going to add our slot. So 5. Radius 2.5. By 6. Center to center spacing. Zero, we want this centered. We've got height and width. Now we need to set up the height from the base. So it's real close there. So what other indicators could we use? Right here. 5.65 millimeters from this to the base, from the bottom to the base of that chord loop. All right. All right. So we have another arc. This time, let's see. I don't know if we specify the arc. No. So I'm going to do that real quick. Because doing it this way, you need that specific piece of information, and you'll see why. So a couple other things we want to note. Based on this diagram, look very closely. Based on what you see in this diagram and this diagram, what is that? What is that region outlining? Anyone recognize what kind of feature that is? Not a sweep. It's a fillet. So the actual arc of the part is this one. So 38.64. Smart dimension tool. Delete that relation. Now, what else do we notice about that angle? As far as where the part is strong versus weak. So we're going to look at this distance. Thought you had a key dimension here, but looks like not. Oh, yeah. Yeah, you do. 5 right there. 5 by 6. So that part should be right. Now we've got sort of really one more thing to add. And that's our rest of our holes here. Trim entities. All right. So now we need a distance here. That will be characterized by this up here. So when you fill it, you lose a little bit of the exterior dimension of something, and that can cause a difference in how you actually measure it. So this 5.84 is actually meant to be about 6 millimeters in the real part, but you don't know that until you've done a few. Now, the way this is going to behave, this area is a little on the thin side. And I can tell you in the real part, it's not all that thick right there. So that's good to know. All right. What is the overall height here? 7.13. That's probably acceptable. All right. So we've got a majority of this. Really, the only thing we're missing are the holes. So we'll add those in. And we want to pay attention to our radii, 1.85 and 2.05. With right now, it has a 34.73 millimeter spacing or pitch. Need them to be concentric. So this right at 1.85. $1.85. Make sure it's working correctly. $4.05. And then we need our separation from the center, which actually I'm going to have to correct. Then I'll have to remake the part. This is why it's important to prototype, as you go, oh man, I put the holes in the wrong place, which is easy to have happen. So 26 millimeters. $13. And then the height should be 24. All right, 24. Okay, this gives you at least a region to work with. This is still surprisingly thin, so I think it's actually a little bit smaller than this. It's a little better. Okay. Six. All right. Have we captured the majority of the detail in the sketch? Yes. So now let's look at what we can do with it. I'll make sure those aren't touching. Good. All right. So I'm not going to try and go for full definition of this sketch right this second. You guys have gotten a lot of practice with that. I'm going to go ahead and do a series of extrudes, and you'll see why this makes sense here in a second. So we're going to do the whole length of this whole region. We're going to do for the width of the whole part. I want to say that's actually like 34. So we're going to say, okay, on this. And then 32. All right, not that far off. 32. All right, 32. Good. All right. So believe it or not, we're actually very close to done. We're going to do another extrude. We're going to select that base sketch that we were just working from. And we are going to extrude this region. And for the back, we're going to extrude that region. So that thickness is, I want to say, 5 or 6 millimeters. I'm going to go figure out real quick. Nope, wrong regions. No, I wanted this region. There we go. So the outer diameter and the inner diameter there are together to make the smaller of the two for the holes. Then we're going to look at this dimension here. So 32, the internal dimensions here are 15.6. So you do some quick math. Minus 15.6. Divide that by 2, and we have our 8.2 millimeters as our actual extrusion. 0.2. Good. Now we're going to repeat that We're going to go back to this base sketch. We're going to just do the outer region, but we're going to do it from this surface and reverse direction. 8.2 millimeters. All right. Now we have one more extrude. We're going to go back to the sketch and we're going to pick this region. Now we have to do something a little different. So the simplest is to start from an offset that we're going to do as 16 millimeters, because that's going to bring us to the center. And then instead of blind, we want to do what's called a mid-plane to center it. So mid-plane and our overall extrusion width based on our drawing, I want to say it's about 9.5 millimeters. Let us double check. Hey, looky there. 9.5 millimeters at either edge. All right. Now we can simply take this whole thing and do a mirror. So in features, as well as in sketch, you can use a mirror concept. So the only other thing we're going to need is a reference plane here at a 0 offset to work as the mirror plane. And you can do faces. But that's not going to give you the same results as if you selected bodies and took that whole thing eliminate the second mirror path to eliminate some of the confusion. And we have our part just minus some of our fillets. All right. So we've basically got the entire part out of a single sketch. How many of you guys didn't think that was possible? One millimeter. All around the outside edge and the front edge. Okay. All around outside edge and front edge. So there's our 1 millimeters. We need our chamfer on the side with the larger holes, which is this face showing toward us. So equally, before you mirror, you can capture some of those features. So instead, I'll show you which ones you can and which ones you can't and why. Before we mirror, we know we have to do a chamfer. at this edge, 2 millimeters, 25 degrees. So we know we have to do a chamfer on the side with the tolerance. We know that we need to fill it at 1 millimeter. So we can do 1. 2 at the same time. Problem is, it's going to select that face. So you can only do so many things. We want this edge. You can only do so many things at once. Okay. And this arc. So we can actually capture all of that level of detail. The one we can't do, and you'll see why, is we can't do this one. If I remember right. Okay, sometimes this will grab this front edge, sometimes it won't. But because it's grabbing this entire edge, it creates a problem. So we want a different result there than for here, based on the drawing. Yeah, we really don't want it pushing quite that far. All right, so you got most of the detail captured. Now you can go back and redo the mirror, and it copies all those other fillets and everything else, right? So it saves you a bit of time only having to do half the drawing. Yes, this one is being recorded because there's a lot of steps. We're going very far in depth into techniques and mirroring and principles for doing complex 3D components, because I want you guys to be completely unintimidated and think the CSWA is the easiest test you've ever taken, because you've had to do assignments for me. All right. So we create the part, then we need a fillet. And this one actually has a larger radius, about 3. This time, I don't think we're going to get away with selecting anything else for that edge. But this one, the whole thing really has a radius more like 3. And that's what's accurately represented by the part. So I think I ended up settling at a middle ground of about 2 for the part. So the idea being, when you go to manufacture this, you don't have lots of really sharp edges built in. You want everything to be kind of naturally smooth, so you don't have to do as much finishing work. You want to try and capture as much of that detail initially as possible. All right. So knowing all this, we now, I think, have the completed part with the corrected version. So yeah, this is a radius of 3, this base. This is the radius of 1 around the outside edge. So that's why in the recreations I've settled on 2, because I haven't been able to get just that one edge to select itself. So we've got, I think, all the geometry. Yep, filleted everywhere. All right, good. So we're there in terms of this part. This is one of the most straightforward ways to get a lot of detail out of a single part. You can do a single sketch and get most of the detail some of the time instead of having to do 8 and 10 different sketches and do a lot of cut operations. So here again, this is why I want to see your part trees so that I can see how you guys are thinking about this. All right, so I'm going to pause it for a second here and see what kind of questions there are and what things we need to address. So sometimes you can get a little better control. The tangent propagation is part of it in terms of the settings. So I could do this to get my 3 down into a 1 for the outside edge. And that is a reasonable operation. So then I could fill it and say this, I actually only want it to be a 1. But then the irony is at the end, you have even a slightly different geometry. So there's a much more aggressive overall radius there. So 2.03 radius on that one. It's like a 1 millimeter radius on the inside. So it was like a 3 to 2 to 1 on the outside. So we've got all of that captured. Then when we go to mirror it, it will bring over the rest of that detail. But we got to make sure we hit both sides. So we actually want to edit. Yeah. We want to include this. Radius for this one, we want to turn off our tangent propagation because I don't want the face. I want the edge. So that needs to be 3. All right. So that's representative of what the actual part is like. One millimeter here to do the blend, not the whole face. There we go. So now we have all of our filleting captured for the part. Great for injection molding. Not as great for additive manufacturing, but can be made to work depending on settings and parameters. All right. So the rebuild function is a good one. We'll take a look real quick because that one's a question that is going to come up. So that's the traffic light up here. So if I went back in and made an edit, this is especially important for this. And I said, oh man, actually, this was, let's say, based on the drawing. Let's say I was wrong and I needed to get it up to 34.73. So I had entered a wrong value. So this 34.73 over 2. So that kicks that back out there. Yada, yada, yada. And then I exit sketch. Now, it technically had to rebuild when I stepped out because it had to move this. So if I went back in, said, oh, nope, I was right the first time. And this goes back to 13. Then you can hit rebuild. And what that will do is that will step out of the current sketch or operation that you're in, bring it all the way back up. I think might be to where the line is. I don't remember offhand, and I don't remember if that's shifted with versions. So let's check that. Okay, so if that actually were 15, let me step it out and rebuild. Yeah, so it's just to where you have the feature line 2, which is how it should be. Okay. So then, yeah, you can't move that while you're there because you'll see the little rebuild when you're editing a feature. This is a thing that you guys have been doing a bunch without even realizing it. So you got it, it won't let you always drag all the way down. It'll stop you a lot of times. So you have to verify that it will rebuild correctly in order for it to be able to drag past that point. So that's how you get in a single sketch all of the detail for a particular part, and you leverage the power of different types of extrusion and different references in order to make that happen. All right, I'll pause it again here and check for additional questions.